Now we're going to look at a shortcut for dividing polynomials, but do be aware that this shortcut only works under certain circumstances. I'll go over the actual process of how to do the synthetic division on the examples. It's something that's easier to show than it is to write out. But basically, this is a shortcut or an abbreviated form of doing long division. And the only operations we'll be performing to get the answer is a bunch of adding and multiplying. So we'll just keep add, multiply, add, multiply, add, multiply until we get to the answer. A couple important rules for when you can use synthetic division. It only works when the polynomial is being divided by something in the form x minus k. So that does mean that you might have x plus k, because that would mean k is a negative number. But most importantly, it means that you cannot have anything like an x squared or an x cubed. So there cannot be any exponents on the x. It has to be an x to the first power, which is what we call a linear expression. Also be aware that if the signs are flipped, so if they have k minus x, or if there's a negative in front of the x, then your first step should actually be to multiply everything in the numerator and the denominator by -1 first, and that'll flip all the signs. You're allowed to do that because if you multiply both the top and the bottom by -1, then technically you're not changing the value of the fraction. -1 divided by -1 is 1, so we're just changing its form, not its value. And then you can set up the synthetic division from there. So keep an eye out for there being a negative sign in front of the x, especially if they flip the order and wrote k minus x instead of x minus k. So always check first to make sure that you can use synthetic division, that it's not one that will require long division. In this case, we have a polynomial, and it's being divided by an x to the first power expression, so that's good. And it is in the form x minus k. Now in this case, since I actually see x plus 2, that means the number I was subtracting must have been a minus 2. So my k value is going to be -2. So your first step is figuring out what number they're subtracting, in this case -2, and write that number in the box. It should always flip the sign of the number that you see here. Next, we just write the coefficients of the polynomial that we're dividing this into. Now, do keep an eye out for any missing exponents. For example, we have x to the third power, x to the second power, x to the first power, and then x to the 0 power. If there's ever an exponent that gets skipped, like if you go from the third power to the first power, then don't forget to fill in a missing 0 in that space. It's very easy to forget that. But in this case, we're only writing the coefficients. So I have 1, -14, 51, and -54, because there are no missing exponents or missing terms in this expression. And then leave a blank row. We'll be filling numbers in here in just a moment, and draw a line. So this is the setup for synthetic division. The number in the box, just flip the sign of what you're dividing by, and then the numbers next to the box are the coefficients of your polynomial with filled in zeros for any missing terms. Now let's look at the actual process for performing the synthetic division. Your first step is just to take the very first coefficient and bring it straight down. In a way, it's the same as what we're going to do in other steps. Whenever we have a column of numbers, we're adding them together. So 1 plus nothing is 1. And then whenever you have a number underneath this line here, that's what gets multiplied by the number in the box. So every time there's a number underneath, take the number in the box and multiply them. And you write that in the next column. So -2 times 1 is -2. And then we just go back to adding. So we did an adding step, then we multiplied by the box. Now we're going to add again. So this gives me -16. Now I have a number underneath the line, so I multiply by the box again. Now I have a column of numbers, so I add them again. Now I have a number underneath the line, so I multiply this again. And then I have one last column of numbers to add, so add them together. And then this does create our answer from the synthetic division process. Now the last number here, this one is always your remainder. The other important thing to note is that our expression began, our polynomial began with an x to the third power. After you do the synthetic division, your exponent should have gone down by 1. So it went from x cubed, now it should be an x squared. So then this is x to the first, this is the x to the 0, or the constant term if you prefer, and then that last one is the remainder. So you can do it either way. You can say, well, I had an x cubed, so now it's x squared, or you can work from right to left and say this last number is always the remainder. So this is the constant, this is x squared, because you might have more numbers here underneath. So it's important to know what is happening with the exponents. So to write my final answer after we've done this division, I would have 1x squared but we don't need to write 1 times the number, so I'll just leave it as x squared, minus 16x, positive 83. And then remember, for the remainder, we write this expression over whatever we were dividing by, the x plus 2 in this case. So I'm going to write minus 220, and the original term we're dividing by was x plus 2, the original polynomial. If it had been a positive number, then I would have written plus that number on top. Now for a more complicated example, again, we are dividing using synthetic division because I do have an x to the first power polynomial here. Now, something important to note right off the bat, though, this does not say x minus 7. This says 7 minus x. So if you're looking back at the earlier slide, this is what I was talking about down here, where I said if you are dividing by a number minus x, then you should multiply both the numerator and the denominator by -1 before setting up the synthetic division. So what I'm going to do is I'm going to change the signs on everything I see here, and I'm instead going to work with x cubed minus 57x plus 56, and we are dividing this by x minus 7 now. Remember, this could have been written as a fraction, so this is the same thing. Division is just a way of writing a fraction. So basically, this stuff is the numerator, and this stuff's the denominator. That's when I was saying multiply the numerator and the denominator by -1. It still works when it is in this form instead of the fraction form. So now we have x minus k, and that means in this case that k must have been a 7. We're subtracting 7, so that's k. So I'm going to go ahead and put 7 as the number in the box. Next, for our setup, we usually write the coefficients of the polynomial. But here's another common trick or common mistake students make when they're doing these. I see an x to the third power, but I do not see an x to the second power. It skips to the first power. So I have missed one of my terms in the polynomial, which means I need to fill in a missing 0 in that spot. So fill in missing zeros whenever there is an exponent missing for the x's. Next, I will put the -57. And then finally, I have the x to the 0 power, or the constant, same thing, and that's 56. So basically, the tricks have already been done. There was the trick of having to multiply everything in the top and bottom by -1 to rewrite the expression this way. If you see a negative in front of the x, or especially if it's in this form, 7 minus, or a number minus x instead of an x minus a number, then flip the signs on everything. And then the second important mistake students make being the filling in missing zeros. So the first number just comes straight down, and then I multiply by the number in the box, add the column again, multiply by the number in the box whenever you get a number underneath this line, add these numbers together, multiply these together now that I have a number underneath, and then something special happens when the numbers do cancel out perfectly like this. That means that this polynomial was divisible by x minus 7 because we didn't get a remainder. In the same way that if I say 15 divided by 3, if you work that out, there's no remainder, so we say 15 is divisible by 3. Conversely, that means if you do get a number here at the end, then the original polynomial was not divisible by that expression. So having a remainder means not divisible by, remainder 0 means it was divisible by that term. So the last step here is let's write our answer now that we've done synthetic division. Remember that we can either subtract 1 from the exponent and say if it was an x cubed expression, now this must be x squared. So I'm not going to write 1 times x squared, that's unnecessary. And then I've got 7x minus 8. Now usually this is how we would write our answer. Since there is no remainder, we don't write that last piece. But if you are doing an assignment that very explicitly asks you to state the remainder anyways, then you would just say plus 0, in this case, over the x minus 7. Usually we will not include this part, but if they really want you to have that remainder in there, that's what it would look like, the remainder over whatever you were originally dividing by. So that's it for the synthetic division process. Thanks for watching.